What's up everyone? Today I will be teaching about scientific notation. I hope you learned something new in this video. Okay, before we get into the explanation, I would like to tell you the definition of scientific notation and show you some vocab that you will need to learn today. Okay, scientific notation is a mathematical expression used to represent a decimal number between 1 and 10. Emphasizing 1 and 10 here. It's very useful for something else. Multiplied by 10 so you can write large numbers using less digits. Scientific notation is very helpful for writing extra large or extra small numbers. So this is just so you don't have to write really big numbers like this one over here all the time on your homework. You can have much neater looking answers like that. Okay, so some vocabulary. We already went over scientific notation because that's the whole point of this video. And some other things we need to learn about. Mantissa. It's the first number in scientific notation. So this number over here is the mantissa. And yes, it can be a decimal. Okay, the next thing I want to talk about is standard form. It's expanded numbers. I mean, really all it means is numbers in their full form. They're not compressed like scientific notation, how we make it so much smaller. It's what we use every day. Like 50 is in standard form. Anyways, that's it for vocab. We can jump into the fun part now. So I'm going to explain how you convert standard form to scientific notation. It's not actually too hard once you get the hang of it. So I like teaching it in a easier way. So just take circle the numbers that aren't 0. Right here, 5 and 7, right? And now, but I will tell you why I circled 1 and 10 here, emphasized it. Let me write it down here. It's because the first number will be what's in the circle, but there are constraints on it that say it has to be between 1 and 10. So to make this a valid mantissa, the head of the number, the first one, it has to be a decimal, and yes, most of the time it will be a decimal. So how would we make 57 into a decimal between 1 and 10? 5.7. There. So now we have our mantissa right there. But now how did we get the second part of the expression? That's because this decimal point isn't valid, because in this full number, the decimal point always starts at the end of it. So as you see, I already have a decimal point here. So first let me just show you something. On any number, like let's just take 57, there's always assumed to be a point right after it. Some of you might know 50, it's all on any number, if there's no decimal after it, it's always assumed to be 0. So that's why the decimal point is here. Anyways, but now we want to move the decimal point from here to here. How do we do that? Well, all we have to do is count. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's just write 10 off to the side here. Circle it. And you won't actually have to do like all of these things later. Once you get really good at it, it becomes fluid in your mind. You can do this whole process in a few seconds. And yes, you will get there one day. So 10, why do we have this? If you see here, multiplied by 10 so you can write large numbers using less digits. Well, that just means you write 10 with an exponent. So the number we counted here is the exponent of 10. So this is the base 10, which will always be there. And then this is the exponent, because we counted 10 spaces. So that's how we got this. And that's really how you got your standard form to scientific notation. Not too hard, is it? Anyways, let's move on to the next stuff. We're gonna do practice. So I'll just give you a moment to soak what I just taught you all in. It might be a little too hard to handle right now, but you'll get it eventually. And I hope you can get it when I show you practice. So how my practice works, my routine is, I give you a problem, I give you 10 seconds to solve it, you're allowed to pause the video if you need more time, and after that I explain it to you. So let me give you a number. It will be a shorter number because I don't want to give you anything too hard quickly. So here, let me. Okay, so this is a relatively small number. I mean, in real life I don't see you putting this in scientific notation, but it's just practice right now, so do it. Anyways, this is in standard form, as I told you, vocabulary. Convert it to scientific notation for me. And you can start now. If you need more time, pause the video. Okay, if you need more time, please pause the video. I will teach you how this is done now. Circle the digits that are not 0. 14. Remember the range 1 to 10. So make this so it's a number between 1 and 10. And remember, it can be a decimal number. So 1.4. It's a decimal between 1 and 10. So now we have our mantissa, don't we? So let's write that down. 1.4, our mantissa, times, you know it's going to be a power of 10 no matter what. So you can just write your base. And remember, the decimal point is here, always assumed, if it's not anywhere else. So we have to move this decimal point here. 1, 2, 3, 4. So that's our exponent, 4, 10 to the power of 4. Okay, I'm going to give you another practice question, this time a bit longer. Remember the range here, and remember the digits that are not 0. And, okay, you can work on that right now. Okay, if you need more time, please pause the video. So circle the digits that are not 0. 1, 9, and 3. Make it so that it's a decimal between 1 and 10. 1.93, our mantissa. And write your base, 10. It will always be 10. The decimal point is always assumed to be at the end of the number, if not elsewhere. And let's move it. 1, 2, 3, 4, 5, 6, 7. 7 spots. So 10 to the power of 7. I'm going to give you one more practice question. This one's going to be a really long one. I'll give you a bit more time to do it. If you need more time, pause the video. If you need more time, please pause the video. So circle the digits that are not 0. Okay? And put the decimal point so that's a number between 1 and 10, a decimal number. Right there. 3.457, that's our mantissa. Times, write your base, 10. The decimal point is here. We need to move it there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 10 to the power of 11. Anyways, I hope you enjoyed today's video and learned something new. Bye and see you on the next video.